Hello everyone, this is Saima, and today in this video we are going to solve a question on derivative. Let's start it.
Question is, find the derivative of x squared at 2. So how we will gonna solve this question? As we have already learned about the definition of derivative, we know that derivative of any curve, this is our y-axis and this is our x-axis. If we have a curve like x squared, this will be our curve for the x squared, and we want to find a derivative at 2. Let's suppose we have 2 is here. Okay, then this will be our point and this would be our x squared, like 4. So we have a point here as 2 and 4, right? Now we want to find out the derivative over here. Let's take another point like this. Let's suppose it is 2 plus h and this distance is h, and this point will be 2 plus h whole square. Okay, we will try to find out the slope between these 2 points, right? So the slope between these 2 points will be the secant line from here to here, and we know that the slope is actually the change in y, which is from here to here. Okay, change in y, which is, this will be our 2 plus h, our x coordinate, and our y coordinate is 2 plus h whole square. Okay, now our slope will be the difference between the y coordinates, like 2 plus h whole square minus this 4, which is 2 square, all divided by rate of change of x, which is 2 plus h minus 2. Here we will get 2 and 2 cancel out, and this will be 2 plus h whole squared minus 2 squared upon h, right? Now, this is actually the slope of this line, okay? Slope of line from here to here. But what we are trying to find out is, we are trying to find out the instantaneous derivative is actually the instantaneous rate of change. Okay, derivative is instantaneous rate of change, but this one is the average rate of change. Average rate of change. Okay, now from here we can find out the average rate of change, which is change in y with respect to change in x. We can find out here minus 4 divided by h. By simplifications, we will get the average rate of change as like 4 plus h, right? We will take common from this h, and that h, this h will get cancelled out. Now, this is the average rate of change, right? Now, but we are here to find out the instantaneous rate of change at this point, which is actually equal to the slope of tangent at this point. Okay, by getting this point closer to this point, we will get the instantaneous rate of change at point 2. Okay, so for this we need to take h, we need to apply limit on h, that h is approaching to 0, which means that we are getting this point closer and closer to this point for better approximation. For this, we actually are reducing the change in x as 0. We will apply limit of this change in x should approaches to 0 of del y by dx. This is actually the instantaneous rate of change at this point, and we call it as dy by dx at point 2. Okay, for this we will apply limit on this point, limit h approaches to 0 for this 4 plus h. When we apply limit h approaches to 0, we will get dy by dx at point 2 as 4. So this is our solution. Thank you.